All right, so next we're going to move on to Group 7, which is led by James Sankool, which they're going to talk about Revit model checks. James,
Hello.
you ready?
Yep, I can share my screen.
All right, hand it over to you.
Yeah, it says presentation.
You can push
model
okay.
check.
All right.
Hello, Walter's and Wolf Engineering Offsite 2020. I hope everyone's enjoying their offsite actually at home during this insight. Anyways,
Just disappeared, James.
we're here to present Revit Model Check Kaizen. My name is James Sankool, and I'll be introducing the rest of the group to you.
Hi, I'm Michelle Sanchez.
Hi, my name is Safari Sophie.
Hello, my name is Michael Vic Chuckwill.
Hi, I'm Jana Sorensen.
Hi, I'm Carlos Aro.
Hi, I'm Ron Nordstrom.
Hi, I am Alan Delera.
This is our scope sheet. It shows some of the current situations and problems we're having and the goals and objectives of what we were working on. A couple of the items are not enough time to perform a model check. This can be caused by late revisions or other items. Caulk joints not matching the details. This can cause issues with glass sizes and that kind of thing. Door dimensions not showing what they're supposed to be. A couple of the goals that we found were that, to create a new checklist with priorities and have more live cuts through the drawings. This will help us with the checking process. Thank you.
How you doing, amiga?
Hi, Anna, how are you doing? How's it going?
Oh, bad.
Oh, what happened?
No, I have a couple things in the model I need you to fix, and I was wondering if you even check the model?
A bit.
So
Did you find errors?
Yeah, I sent you the list. Did you see the list?
I did see an email. Let me check that right now. You see this email?
Yeah, that one. Yes.
Oh wow, that's a long list. Are all of these the issues you found?
No, mostly over here, and questions about the model here. Things, do you actually have a Revit model checklist open? Do you know where it is?
I only have the model open. I don't have a checklist, but let me try and find it. I know it's hard to find it sometimes.
Here you go. Just like 2 hours late.
I know. All right. I did do, I think, steps 1 through 2 and 3.
You did,
but it was super long, Yana. Really, to be honest, it was just too long.
But I have to release metal tomorrow. Can you check it for me?
Yeah, I've been working on a different model, but you know, I'll do this for you. It's just gonna take a while. So what was the first issue?
No, let's look on the detail. Let's go on page 214.
Would this be the only elevation, or are a lot of elevations wrong? Because I would literally have to go through every single mullion in the project.
You have to check them all now. I don't trust the model.
Yana, it's gonna take forever. It's like doing a whole model check over again.
No, what can I do? I mean, it needs to be checked.
Yana, do you know what I have to do? I literally have to click each mullion of every single elevation, go into my detail, and if there's not a detail, I have to create a new view.
Oh yeah, also I need you to check the joints.
The joints too?
The joints too, like if you look on the right side of this elevation. Maybe you can have another session open and have the details open there. I don't know.
Okay, I'll get this done for you, but just letting you know, it's a lot of work.
Oh man.
But you're right. I should have checked first. I should have done a whole model check from step 1 to the last step, and this would have avoided all these issues. And then I would be frustrated. All right, Yana.
All right, Michelle.
I'll
Thank
get
you.
to it.
All right.
Bye.
Bye.
Hi. Our current state process map. We start checking the model 3 weeks before metal takeoff. First, we open the Revit model checklist. We make sure all families and generic models have takeoff components. We make sure all the elevations have quantities. We make a list of all the profile modifiers. We check for inconsistencies in glass, elevation keys, and unit keys. We also check for the length of the anchor tubes. We made life cuts through doors and operable beds. We backcheck door dimensions against the architectural drawings. We also check the quantity of elevations against our floor plans. And that's our current state.
Hi everyone, I'm going to show you the model checker tool. Once you click the button, this model checker hub will pop up. Inside of the hub, there are steps for conducting the model check. These steps are located in the checklist, which is on the very left, and each of these steps also has a respective tab with either a tool or directions on how to complete that step. Now inside of the actual checklist, it lists the step, the potential tool to use to do the step, a little description of the step, and in the future they'll all have a video link describing how to do the step. So for step number 1, check takeoff components, you would go to number 1 takeoff components tab down here, and there's a tool to do the takeoff components check. Going back, step 2, check elevation numbers. It's much of the same thing. You would go to number 2 elevation numbers tab, and there's a tool inside of that tab to complete the step. Now number 3, check reference elevations. Same thing. There's a tab with a tool to complete that check. Now some of these steps, for example number 8, check operables and vents. That one doesn't have a tool right now. And those ones that don't have tools will say over here. Some of the other steps require the use of Zach's takeoff browser, and it'll specify if it needs the takeoff browser. For example, 9, check mullion heights, and if you navigate to the tab, it'll tell you to use a takeoff browser. When you do this check, you'll go through all these steps, and when you've completed a step, you can hit this checked column. It'll turn green, and just so you know that you've done the step. And that's it.
Step number 5 is a detailed back check. In this step, what we're really checking is that all the profiles are matching from elevation to details. I go into the detail back check tab here, number 5, press get started. You do have an option of your full scale elevations and your 1/4 inch. Now you're going to choose your elevation. You can choose it through here and continue on. Make sure to press select, bring in the elevation you selected into your view, and then it's going to bring up all the issues that are here. It's extracting all the data from your model. It's comparing your mullions with the details that you marked, and it's telling you, kind of gives you a brief summary of all the issues that you have within this elevation only. So right away, this first issue, since it's highlighted in yellow, we know that our issue is in the joint that we have. So the joints, probably from the detail and the mullion, are not matching. Jump here where it says joints, and you can see that inside the model in the profiles we have 3/4 inch joints, whereas in the details there are no joints. Simply double click and it's going to take you right to where this issue is happening. you can always come back here and on the call out name and make sure that it's calling out the one you're choosing. So I know it's this one. As a drafter, I know that my joints are correct for both my jamb and my head, so that the issue must be with the detail. And oh, it's wrong. So probably this detail was just misplaced. Since it's really close at this transition, it really is supposed to be moved. So technically this step is complete. This issue has been solved. I check in here and move on to the next. For this one, again, it's a mullion issue. And we can see that inside our details, there is no assigned mullion. Yet, of course, in our model, we do have mullions. So we double click here to take us to our issue. And again, it says the detail doesn't have any data. So let's just check that in. And this looks like just line work. So obviously it's not going to have data. And this is just a part number. Is correct. And we'll move on. So this is pretty much the process that you would be doing for every elevation and every issue. The data here also allows you to see all of your callouts and all of your profiles inside this elevation with issues or no issues. If you are ready to move on to the next elevation, you can simply just press next, and all of the data within that elevation will load in here as well.
I'm going to show you how to use the anchor tube check. Click on Get Verse 6 and then click on Get All Anchor Tubes. This will get all the anchor tubes in your job. Check all these anchor tubes if there's any inconsistencies or missing information when it comes to the level offset, tube length bottom, tube length top in the elevation view. The level offsets will usually be 1/4. Tube length bottoms will be relatively the same when it comes to each Mac, and so is the tube length bottom, depending on the level and depending on the Mac. We get to the bottom here and we have missing information when it comes to the level. This Mac 11, everything needs to be set to a level, so what you want to do is double click the Mac. It will show on your top browser here. Click on the Mac 11. As you can see, it's associated to the second level. Go to the Properties browser. Go to the bottom where it says Schedule Level, and assign it to a level. It won't show up here until you basically refresh all the anchor tubes. I will go ahead and set all these Macs to the level. When I refresh, all the levels are assigned and there's no missing information. Also make sure the level offsets are filled and all the other information.
How to check doors for your model check. First, you'll need to have your door schedule from the architecturals. Open, go to tab 7, door checker tab, and click Get Door Data. Here you'll see a list of all the doors. You can move these tabs. You can filter by each tab. I'm going to move the mark number to the left and filter by mark number. You'll want to check the mark number for each door and compare the door height, the door width, and the mark number with the architectural door schedule. You want to make sure that each door has the Walters & Wolff glass checked. You'll also want to check the door offset. By double-clicking on a door, you'll see the elevation. You can click on the detail to check what the offset needs to be, or you can also look at the offset tab. Cut horizontally and cut vertically to check if the door offset indicated is true. Check if your door is in swing or out swing. Also check to see if you have the correct pocket filler. And overall, if your door matches the detail.
So what's next? Well, we've already used the tool on a couple projects, Matilda, Ardenwood, 1951 Harbor Bay. We still have a few more projects coming up, Santana West, Samaritan, El Camino. And based off of the previous jobs that we've done it on, we've already taken that feedback and implemented some enhancements. So really, the videos that you saw earlier in the presentation is not the first iteration. So we are going to continue to PDCA this tool, as well as create additional training videos.
When are you dropping the soundtrack?
What was that?
When are you dropping the soundtrack?
Dropping the soundtrack?
Yes. Of all the music you use in the background.
She wants to keep it going. Turn it up.
Oh, okay.
Yep, fall asleep with it.
She's enjoying it.
I mean, it would be it for me.
Great music.
Well, everyone has that on Windows Video Editor, so.
Good job, guys.
Really good job.
Apologize for the earlier technical difficulties.
No, it was a great presentation.
I got one item that stood out for me. It has to do with step number 5, detail back check. As you select your completed and you go to the next one, at what point do you go back to make sure that your change it's truly like correct? Meaning like, what if you didn't do it right? Are we going back to it at any given time?
Or you can actually refresh, and it's going to make sure that on the summary it's completed.
Sweet, thank you.
By refreshing, yeah.
On the door check, because you mentioned checking the widths, so I had 2 points. So we have to make sure that the single doors are 3 feet and the double doors are 6 feet. So is there something that triggers, because even sometimes the architectural door schedule has them as weird sizes or sizes are too small or too big, you know, or not too big, too small usually. So just kind of, is there a way to flag those, even though you may match, but do you know to make sure it's not 2'9" 3/4 door opening? And know that it should be 3 foot minimum.
Well,
stuff like that.
yeah, that's more of like a job condition thing, because there's even some cases where doors could be smaller than 3 feet if they're not like egress doors, such as like mechanical or electrical rooms. We've had a few projects like that. But it is something that, you know, we should probably look for though. Like if it is.
Just confirm it's correct then for that job. And then the other question I just had was headers. Because those two usually cause problems, that the wrong header is not shown and that affects door openings. So again, this is part of the stuff that me and Elena were checking later, but I don't know if it's part of this check, if it could be, to make sure if you have a special door header, does the drafter know it? Is it drawn right? And is your door sized properly? Because those are usually caught later, but it could be nice if it could be at least a point here to check it, or.
Yeah, I think I just forgot to mention that in the video. I can, these are going to be training videos, so I think I can just add something in the video to remind the drafter.
You can also add something visual too to the tool itself.
So in Sahara's scope, what does it mean or indicate if Walters and Wolf glass is not checked?
It needs to be checked so that takeoff group will pick up this information. If it's not checked accidentally, it's not gonna get translated for us.
For instance, if it's an in-swing door or an out-swing door, holes have to be prepped at the bottom of the vertical. And if it's not identified as one or the other, the holes could be in the wrong location. And that could be a problem. That's some of the stuff that happens if you don't have the information correct in the model.
There is an option for windows and vents. Do we have louvers in the model check?
Yeah, I think if the right now we do, yes, we can. It's all the panels, glazed in panels we can check.
Well, there was a section in there. There is a few like manual checks, and I believe the louvers was one of those things that Alan mentioned in his overview.
You can still check
I
it
think
with
that could be
the
checked
panel.
with the takeoff browser,
Yeah,
right?
it can be checked with the takeoff browser too. Yeah. It's just like a glass. You can check the louvers too.
I have something to say about the model check. So I have used the first time for Matilda, and so I really have some experience want to tell about probably a bug. So if you make an elevation already with Allen's tool, and if you place the wrong mullion, and of course the reference call out that you use Allen's tool will depends on what mullion you place in. But if your mullion is a wrong mullion, then when you model check, it will follow still the wrong call out because your original mullion is wrong. And we rarely catch that in some of the material location because originally the mullion is wrong. So I don't know how the model check tool can find the problem out, because this has to be catch maybe by human, not the program, because the program will think everything is consistent, except we are the one that knowing this is what not matching the architecture. Is it making sense?
Totally, you still have to kind of know your project and think
I
about
think Yana know what I'm talking about, because originally that's a mullion is placing wrong. And then you use Allen's tool and you place the wrong call out. And if you use model check tool, the model check will still go through because it didn't call this is the wrong detail, because the mullion originally is wrong and the gas fire is wrong too because it's the wrong mullion. So just yeah, I don't know if there's something can be improved in the model check, or
I don't think we can ever completely eliminate human check out of that. You still need to know your project. It's just, I think the biggest thing what we did, we moved it from the wiki somewhere in the deep in the wiki, right, in the Revit. So
yeah,
it becomes a little bit more convenient. Not a little bit more, it's hugely more convenient.
It's nice that it's actually got a list that you can click in order, and it's in the model.
Yeah, so just make sure you don't trust the model check too much and still use your human knowledge.
Yes, I absolutely agree.
Have you guys established a duration for model check with the new process? I know it's still in the beta test, but meaning like that way we know how long it's truly going to take, so we're realistic when we are told do the model check, and then we know, okay, 3 days, 2 days, a day.
I think it depends on the project, and I think it's still at least a week in my opinion if you want to go through all the steps, and if it's a normal size project.
I've been scheduling like 3 days. We haven't done any time trials with this new model checker tool, but as we're continuously using this, you know, maybe the time duration will be updated.
You really should be running this check after you draw the elevation to begin with. There shouldn't be something at the end. You should draw the elevation, do the model check on that elevation, then move on. And you shouldn't be doing 3 days at the end. Like draw one elevation complete, finish it, check it, never talk about it again.
It was one of the objectives because we were not able to kind of do it before, and now we can do it per elevation.
Yeah, so earlier in the presentation, we did mention that we wanted to use this tool like after each elevation, but we still don't want to abandon, you know, not using it at the very end as well, because there are some little changes that come through that we might have missed checking previously. So just before it gets to takeoffs, we would like to just run that final check just to make sure again.
I also want to mention, Steve, that in Revit world, you can model something and check it and it's 100% complete. And at some point, you change one other element or it accidentally gets clicked. And it's not like CAD, you close the drawing and never open it again. You don't have to worry that anyone changes it. In Revit, you could have something in the project get moved or changed and not even realize it. So it's good to still double check at the end.
In Revit.
At least you're not going to find as many errors at the end if you check it per elevation, which would be a better start as you go through. So you'll catch most of it as you're going, and then at the end you may have a few hiccups that happen at the end, which might make that final check a lot less time.
Yeah, so that 3 days could hopefully be whittled down to like 1 day or half a day or even an hour.
This is a beautiful tool, though. Nice job.
Nice job, Alan.
All right, good job, guys.
Really
Everyone
good
on
job.
mute.
Thanks, Alan.
Applause.
Guys.
Yeah, that was awesome.
Yes.
Best presentation so far.
Oscars for
Raising the
best,
bar.
the Oscars for best editing for sure.
How am I supposed to follow that?
How are we supposed to follow that?
Muting everyone.
It's okay.
Can we play?
All right, good job, Team 7.